between the ventricle and the artery, the big artery, either the aorta or the pulmonary artery. Those are called semilunar valves, and they're kind of a little bit weaker, and that blood under pressure is going to open them. But then, when the heart contraction stops, you don't want the blood going back from the aorta into the heart, right? So that's now the pressure of that blood is going to close them, and so it cannot go back. It has to stay in the aorta, and the next push is going to push it away, and the next push, and the next push, and the next push. So that's why we have those two semilunar valves, and then the valves in between the two atria and the two ventricles are bicuspid or tricuspid. Bicuspid is on the left because it has two cusps, right? It has two flaps. It's also called mitral valve because it's reminded some old anatomists of a mitre that some Catholic priests wear, like a hat. While the right one is tricuspid because it has three flaps. And it's kind of easy to remember. In English, we're writing from left to right, so when you write the numbers 0, 1, 2, 3, 4, 5, 6, the one that's lower is on the left, the higher number is on the right. So on the left is 2, on the right is 3. That's how you remember it, okay? So bicuspid on the left, tricuspid on the right, and that is how you remember which side of the heart is each one goes in. All right. So when you have the
Say it again, sorry, I got you. It's the
tri is on the right and bi is on the left. Okay. So we are going to have now this heart is contracting, and left ventricle is pushing all that blood into the aorta. This is the aorta or aortic arch. So this first part is happening in the thoracic cavity, so that's thoracic aorta. And then it's going to go through the diaphragm into the abdominal cavity, which is called abdominal aorta. And as it goes, it's going to split. It's going to have various arteries branch off of it, like the celiac, which branches into 3 others, like gastric and hepatic and splenic, which go to the stomach, the spleen, the liver, and the spleen. And then you have the left and right renal artery that go into the left and right kidney. And then at the end, it splits into 2 common iliac arteries that are then going to, split into several different arteries that go down the legs. The first 3 arteries that go here, you need to know. This one is called brachiocephalic artery or brachiocephalic trunk. If you watch something like Grey's Anatomy, they're going to be all very smarty pants, and they're going to call it innominate artery. It's a very medical, I'm a doctor kind of thing, right? I know obscure terminology, right? It's innominate, which means no name, right? And then they gave it a name, it's brachiocephalic. Fine, brachiocephalic trunk. If I ask this in an exam, you tell me it's brachiocephalic trunk. Don't be a wise ass, okay? So it's brachiocephalic trunk. Brachiocephalic trunk is going to then split into the left subclavian and the left common carotid. Left subclavian artery, right subclavian artery is going under the right clavicle, right? And then it's going to go into the right arm. So it's going to feed the right arm. Right common carotid is going to go up to the neck, into the skull.
Say the name again.
Common carotid. Common carotid. Yeah. Don't confuse me. Common carotid. I'm trying hard. Common carotid artery is going to go into through the neck into the head. It's going to split into the external and internal carotid artery, and it's going to feed the head, and it's going to feed the brain, right? The internal carotids are going to make an anastomosis. Arterials have an anastomosis, which is called the circle of Willis. Circle of Willis is 5 little arteries in the base of the brain that are feeding each other. So if one of them gets clogged, the blood can go around and still feed all parts of the brain. So you don't get brain, ischemia, and just because of this tiny little artery got clogged. So circle of Willis. Circle of Willis. If you look at him in Wikipedia, and I'm sure I have a link to him somewhere, and maybe additional readings or somewhere, here's a British guy who described this. He described a lot of other things. He was, for instance, the first person to describe the symptoms of diabetes. And for a long time, diabetes mellitus used to be called the disease of Willis. And then it was changed later, right? Because he was the first one to really describe the whole, symptomatics of the diabetes mellitus. So circle of Willis is going to be on the base of the brain. Okay, the second artery coming out of the aortic arch is going to be the left common carotid, going on the left side of the neck into the brain, again splitting into the internal and external, and internal is going to feed into the circle of Willis. This one is going to be the left subclavian, going under the left clavicle into the arm and feeding the arm, splitting into, radial and ulnar.
What's that again? Left subclavian.
Left subclavian. Okay, so this model is beautiful, and we are always fighting over it because we can't find another one like this that has these really nice and long. You know how easy this is to label for the practical? I can do it, half asleep. A, B, C, which one is this, which one is this, which one is this? And you will know those, right? Most of these, they cut them short, harder to see, harder to label. Or it's not really anatomically very correct like these, right? So I'm going to use this one for the lab practical to ask you for these. Now, what is the most important thing to remember about this? Yes, you're going to remember the names of
You're
these.
only going to use this one. You're only using that one.
I'm going to use this one for these arteries. I can use other heart models for ventricles and atria. This is the apex, and the wall between the ventricles. I can use all sorts of other models for that. But for these arteries, I'm going to use this heart. This is the good heart, as we call it around here. The good heart. And you're going to know this. You have to know this because it's the most common situation. What does it mean in the most common situation? If you're a cardiac surgeon and you open up thousands and thousands of people to do heart surgeries, about 80, maybe 85% of the people you open up are going to have this configuration. The others, 10 to 20%, 15 to 20% of the people are going to have different configuration, anywhere between 1 and 7. And they're all considered normal and healthy. You can go to the Olympics, run a marathon, and you never know unless they do an x-ray or you have to have heart surgery, and then they realize you don't have these 3, and then this one's splitting into 2. Because all this branching can happen earlier or it can happen later, right? So you can have just one artery coming out and then splitting, branching into all the others. Or you can have all, first 7 branches coming out all directly out of the aorta. And all of that is normal. There are pathological things, right? And they're going to be immediately visible in a newborn who never gets the, what's the name of that number? 0 to 10 when it's just born? God. The mother's here, right? They give you a number of how good the color is of the baby and all that. Huh? That's right. Thank you.
What is it again?
Oh, yeah.
You're not going to get a 10. Immediately, x-rays, whatnot, what's wrong with the heart, right? A good friend of mine is a pediatric cardiac surgeon. Those hearts are tiny little things, right? And you have to fix them. Another good friend of mine has a son who, after several surgeries, essentially has one tube here and can't travel on the airplanes. So travels all around Europe in boats and van. They have mobile homes so they can travel around. He can never get to America to visit because he can't get on an airplane because of that. It's really, really tricky. So there are pathological situations, but don't forget, there are a lot of situations that are perfectly normal because all the body parts are going to get the normal quantity of blood at normal pressure, no matter what. So there's a lot of fuzziness here. There's a lot of differences, there's a lot of individual difference in the population. It's not all like the textbook, as I told you already a couple of times before. Your textbooks are lying to you. They're giving you the most common situation instead of presenting you all the variations that exist in the human population. The same thing with other arteries and veins. For instance, when you are just developing the cardiovascular system, so you're still a fetus, you have the radial artery and you have the ulnar artery. And in between them, you have a median artery. So there's three. And by the time you're bored, the median artery kind of shuts down and disappears. More and more people are now having what is called the persistent median artery, right? So it persisted into adulthood. You have three instead of two, which is wonderful. If one of them gets clotted or injured or something like that, the other one can feed a hand. So it's kind of nice, and it's coming back. I don't think there's any selective pressure for it. It's just randomly coming back, a random walk of our genetics. So there are individual variations. If you could go to additional readings, you'll find a lot of those, both the nerves and arteries and veins, which are found in unusual places, or brain